Proxima Centauri b is our nearest known exoplanet neighbour, just 4 light-years away. This M-type star has an orbiting exoplanet called Proxima B. It was discovered and published in 2016 using the radial velocity technique, which detects variations in a star's radial velocity produced by the gravitational attraction of an orbiting planet. However, NASA just announced the clearest image ever taken of Proxima B, as seen by the James Webb Space Telescope. The image suggests that Proxima B could be a habitable planet around the nearest star to Earth. Do you understand the implication of this discovery to our planet and life? Stay tuned for the most shocking revelation. Proxima B is a rocky, Earth-like planet with a mass about 1.3 times that of Earth. It orbits its star every 11.2 days at approximately 0.05 astronomical units, significantly closer than Mercury's distance from the Sun. Proxima B is tidally locked to its star, which means one side constantly faces Proxima Centauri. In contrast, the other side is eternally dark. This might result in substantial temperature changes between the two sides of the planet, which could profoundly affect its habitability. Despite its near closeness to its star, Proxima B is in the habitable zone, the area around a star where circumstances are suitable for liquid water to exist on the surface of a planet. This makes it a prime target for the search for extraterrestrial life. Due to its proximity, it has become a subject of study and a possible target for future exploration. According to research, Proxima B experiences periods of severe ultraviolet radiation hundreds of times more potent than Earth does from the Sun in the habitable zone of its star Proxima Centauri. Such radiation provides enough energy to tear away not just the lightest molecules of hydrogen, but also heavier components like oxygen and nitrogen over time. This means there is a chance that water exists on Proxima B and has an atmosphere that protects it from extreme heat while also scattering heat to its dark side. Proxima B's orbit lies in the habitable zone, the distance from its host star where liquid water may pool on the planet's surface. However, it's not livable. It does not consider, for example, whether water exists on the planet or if an atmosphere could survive in that orbit. Atmospheres are also necessary for life as we know it. They allow for temperature management, the preservation of water-friendly surface pressure, protection from dangerous space weather, and the storage of life's chemical building components. Many investigations on Proxima B have been done to better comprehend its properties and possible habitability. In 2018, a study found the planet's atmosphere could be thick and dense, which could help regulate temperature differences between the two sides of the planet. This would make the planet more habitable than previously believed. In 2020, another study suggested that Proxima B could have a global ocean on its surface, increasing its potential for habitability. Considering its closeness, investigating Proxima B would provide a formidable obstacle. The fastest spacecraft ever launched by mankind, the Parker Solar Probe, would take more than 6,000 years to reach Proxima Centauri. This implies that any journey to study Proxima B would need significant breakthroughs in technology and propulsion systems. Thankfully, NASA spearheaded the design and development of the James Webb Space Telescope, or the JWST, in collaboration with the European Space Agency and the Canadian Space Agency. A significant goal of the James Webb Space Telescope is to hunt for habitable exoplanets, so that one day we may search for signs of life outside of Earth. Determining whether a planet is habitable is not easy, and finding another Earth-like planet may be pretty challenging. Even worse is that Proxima Centauri is not visible to the human eye, as one would anticipate from the closest star to the solar system. It has a relatively low average brightness and is extremely tiny compared to other stars, weighing just approximately 1/8 of the mass of the Sun. Proxima is a flare star, which means that convection processes inside the star's body cause it to undergo unpredictable and dramatic fluctuations in brightness. Convection processes provide dazzling bursts of brightness and, when coupled with other considerations, indicate that Proxima Centauri will live for a very long time. Scientists expect that this star will stay middle-aged, or a main sequence star in astronomical terminology, for another 4 trillion years, or around 300 times the present age of the universe. On rare occasions though, its brilliance rises. Telescopes filter out various wavelengths using detectors and cameras, ensuring that only the appropriate wavelengths are collected and electronically processed for viewing. Compared to its predecessors, JWST includes more sensitive detectors, including the mid-infrared camera and near-infrared camera, that can observe the spectrum of infrared light and provide us with crisper, more detailed images of light from billions of light years distant. Since various wavelengths of light depict different processes and occurrences in space, studying the infrared spectrum provides a new viewpoint and lens for our universe. Consequently, infrared is preferred over longer wavelengths, such as microwaves or radio waves. Compared to other wavelengths, infrared light's capacity to penetrate through thick and cold clouds of dust and gas, a phenomenon known as redshift, and the link between wavelengths and temperature are the three fundamental reasons for JWST to use infrared observation. NASA's new image explains the artistic impression of the planet, which shows a view of the planet's surface. These images also confirm that Proxima Centauri is part of a three-star system. Its neighbors, Alpha Centauri A and B, are in the background. The system is made up of the pair formed by the stars Alpha Centauri A and Alpha Centauri B, as well as the dim red dwarf Alpha Centauri C, also known as Proxima Centauri. The Space Telescope captured this breathtaking image of the brilliant Alpha Centauri A and Alpha Centauri B, which sparkle like giant cosmic spotlights in the dark. Observations at optical and near-infrared wavelengths created this depiction of Alpha Centauri. Alpha Centauri A, a G2-type star, is somewhat more extensive than the Sun. In contrast, Alpha Centauri B, a K1-type star, is slightly smaller. They circle a shared center of gravity once every 80 years, with a minimum distance of around 11 times the Earth-Sun distance. Since these two stars are the nearest to the Earth, along with their brother Proxima Centauri, they are among the most studied by astronomers. They are also ideal candidates in the search for habitable exoplanets. Before NASA's image, little was known about Proxima Centauri B, except for its distance from the star and orbital period. Several simulations and models based on Earth-like compositions have been developed, including predictions of the galactic environment, magnetic induction heating, internal heat generation from radioactive decay, planetary rotation, the effects of stellar radiation, the number of volatile species the planet contains, and the changes in these parameters over time. If it originated at its present distance from the star, Proxima Centauri B most likely formed under different circumstances than Earth, with less water, more complex impacts, and quicker overall development. The material in the protoplanetary disk would be inadequate to construct Proxima Centauri B at its present distance from Proxima Centauri. Instead, it or pieces developed at further distances and subsequently traveled to Proxima Centauri B's current orbit. It may be high in volatiles depending on the nature of the precursor material. Various creative scenarios are feasible, many of which rely on the presence of other planets in the vicinity of Proxima Centauri and would result in diverse compositions. However, continued study of this fascinating planet will help us comprehend the nature of exoplanets and the likelihood of life beyond our solar system. We hope you enjoyed watching this video. If yes, we're sure you would like this next video here. Thanks for watching.